You've probably heard of the Ring of Fire, but what you may not have known is that hiding beneath its turbulent waters are some of Earth's most dangerous supervolcanoes. While the Ring of Fire is notorious for its volcanic activity, these underwater giants are particularly intriguing because they don't play by the rules. But what exactly makes a volcano go super? And how do scientists keep tabs on these hidden threats when they're, well, under wraps? Join us as we dive deep into the ocean depths to uncover the secrets of these mysterious underwater supervolcanoes. Our journey begins at the Mariana Islands, a volcanic archipelago in the western Pacific Ocean. The Mariana Islands are home to more than just breathtaking landscapes. Beneath the surface lies one of the world's largest underwater volcanoes, the Great Barracuda. This massive volcano stands over 2,000 meters tall and covers an area larger than Australia. Despite its imposing size, the Great Barrier Reef has remained relatively unknown until recently. In fact, it was only discovered in 1814 by Spanish navigators. Its remote location and incredible depth, nearly 3,000 meters below sea level, have made it a hard nut to crack. Yet despite the challenges, scientists have managed to piece together its history through careful study. The Great Barracuda is part of a much larger structure called the Mariana Islands Arc, a chain of volcanoes formed by the subduction of the Pacific Plate beneath the Philippine Sea Plate. As the two plates collide, the denser oceanic crust of the Pacific Plate dives beneath the Philippine Sea Plate. This process, known as subduction, leads to the release of water and other fluids from the sinking plate. These fluids, combined with the intense heat and pressure, create a perfect recipe for volcanic activity. The magma generated rises up through the Earth's crust, eventually forming new land. Over millions of years, this has resulted in the formation of the Mariana Islands Arc, including the Great Barracuda. Now let's talk about what makes a volcano super. It's all about the eruption, specifically the Volcanic Explosivity Index or VEI. This scale ranks eruptions based on factors such as the volume of material ejected, the eruption duration, and the height of the eruption column. Supervolcanoes are those that have an index of 8. And this is where the story of the Great Barrier Reef takes a dramatic turn. Scientists have estimated that the Great Barrier Reef's VEI is a staggering 8, making it a true supervolcano. However, there's a catch. The Great Barrier Reef hasn't erupted in millions of years. It's currently dormant, which brings us to another critical aspect of these underwater giants, their accessibility. While many volcanoes can be studied extensively during their active phases, the Great Barracuda's dormancy poses a unique set of challenges. Limited observation makes understanding its behavior and predicting its potential reactivation tricky. Despite the difficulties, scientists are working tirelessly to unlock the secrets of this sleeping giant. By studying its composition, structure, and geological history, they hope to gain insights into its behavior and the risks it might pose in the future. Recent studies have focused on analyzing samples of the Barracuda's lava, hoping to find clues about its magma chamber and eruption style. Unlocking the secrets of the Great Barracuda is crucial not just for understanding the dynamics of underwater volcanoes, but also for unraveling the history of the entire Mariana Islands arc. As we continue to explore this fascinating region, we might just find that the Great Barracuda holds the key to understanding the explosive past of our planet. But our journey doesn't end here. Let's now turn our attention to another intriguing location, the Tonga Islands. Tucked away in the South Pacific Ocean, the Tonga Islands are a scattered archipelago that holds many wonders. Among them is the Home Reef, a submarine volcano located south of the main island, Tonga Tapu. Unlike the Great Barracuda, the Home Reef has been more active in recent times. In 2006, it made headlines when it began its first recorded eruption since 1852. The eruption lasted several weeks and created a lava lake that spilled over the rim of the crater, but the Home Reef's behavior has been anything but predictable. In 2012, it surprised scientists by erupting again, producing a massive explosion that sent ash high into the atmosphere. This unexpected outburst raised concerns about the volcano's potential impact on the surrounding environment. You see, unlike their terrestrial counterparts, submarine volcanoes like the Home Reef can catch us off guard. Their eruptions don't always display the telltale signs such as earthquakes or ground deformation that precede land-based volcanic eruptions. Instead, they often erupt explosively without much warning. The Home Reef's surprise eruptions highlight the unpredictability of these underwater giants and emphasize the need for constant monitoring. Now you might be wondering, how exactly do scientists keep tabs on these hidden threats? Well, the answer lies in a network of sophisticated instruments and cutting-edge technology. For instance, seismic sensors are deployed on the seafloor to detect any signs of unrest, such as increased earthquake activity. These sensors can provide valuable insights into the buildup of pressure beneath the seafloor, helping scientists anticipate potential eruptions. Another powerful tool at their disposal is satellite imagery. Satellites equipped with thermal sensors can detect changes in temperature on the seafloor, indicating areas of heightened volcanic activity. This can help pinpoint the location and intensity of eruptions, even if they occur in remote areas. But perhaps the most exciting development in the field of submarine volcano monitoring is the use of unmanned vehicles. These autonomous robots can venture into the depths of the ocean to collect real-time data on underwater volcanoes, providing scientists with a level of access and detail previously unattainable. For example, unmanned submersibles equipped with cameras and other instruments can capture stunning visuals of underwater eruptions, allowing researchers to study them in a non-intrusive way. These technological advancements have revolutionized the way scientists monitor submarine volcanoes. By harnessing the power of seismic sensors, satellite imagery, and unmanned vehicles, they are better equipped than ever before to understand and predict the behavior of these enigmatic giants of the deep. The Home Reef is part of a larger volcanic region known as the Tonga Island arc. This arc, like the Mariana Islands arc, is formed by the subduction of the Australian plate beneath the Pacific plate. The subduction process generates immense heat and pressure, leading to the formation of magma that fuels volcanic activity in the region. The Home Reef's most recent eruption serves as a reminder of the dynamic forces at play in this region. The eruption not only sent ash into the atmosphere but also created a new island, illustrating the incredible power of these underwater volcanoes. Monitoring the Home Reef and other submarine volcanoes in the Tonga Island arc is crucial for several reasons. Firstly, volcanic eruptions, especially those in remote areas, can pose significant risks to shipping and aviation. The ash and gases released during an eruption can disrupt air travel and pose hazards to ships navigating the region. Additionally, submarine eruptions can trigger tsunamis, although this is less common than with land-based eruptions. The Home Reef's proximity to populated areas makes it particularly important to understand its behavior and potential hazards. As we continue to explore the depths of our oceans, we are constantly reminded of the awe-inspiring power of nature. Submarine volcanoes like the Great Barracuda and the Home Reef stand as silent giants, shaping our planet's history in ways both grand and subtle. By unlocking their secrets, we not only deepen our understanding of the Earth's dynamic processes, but also gain insights into the very origins of our planet. The Mariana Islands and the Tonga Islands are just two examples of the many regions around the globe where these underwater giants exist. From the Java Trench in Indonesia to the Mariana Islands in the Western Pacific, these regions are home to numerous submarine volcanoes that contribute to the Earth's volcanic tapestry. Exploring these sites not only helps us comprehend the forces that shape our planet, but also allows us to appreciate the beauty and complexity of the natural world. Each submarine volcano has its own unique story to tell, shaped by millions of years of geological history. By unraveling these stories, we piece together the grand narrative of our planet's evolution. Now check out this video on the Ring of Fire to learn more about the Earth's turbulent belt. Or click here to explore another captivating topic. Don't forget to subscribe for more exciting journeys into the heart of our amazing planet. Thanks for joining us.